Picture this. You're enjoying a plate of fish curry or fish fry, but what if I told you that nearly half of that fish never makes it to your plate? In fact, every year millions of tons of fish parts like heads, bones, skins, and guts are thrown away. That's nutrient-rich protein, healthy oils, and bioactive compounds wasted. But here's the twist. Scientists and industries are discovering mind-blowing ways to turn the so-called waste into animal feed, medicines, beauty products, energy, and even eco-friendly fuels. Welcome to today's video where we explore the hidden gold inside fish waste and how it could help solve pollution, food insecurity, and even climate change. Fish is a vital source of protein globally, providing about 17% of animal protein intake. But here's the shocking part. When fish are processed, whether filleted, gutted, or scaled, 30 to 80% of the biomass is discarded. That's not just inefficient, it's unsustainable. Think about it. The fish industry also consumes huge amounts of clean water, producing tons of wastewater. Instead of letting all this go to waste, researchers are now focusing on bioconversion and value addition. In other words, turning fish scraps into valuable products that can benefit food, agriculture, medicine, and energy sectors. When fish waste is dumped in oceans or landfills, it doesn't just disappear, it pollutes ecosystems. Bacteria start breaking down the organic matter, consuming oxygen in the water. This creates dead zones where fish and aquatic life suffocate. Excess nitrogen and phosphorus cause algal blooms, a process called eutrophication. And as these algae decompose, toxic gases like hydrogen sulfide, methane, and carbon dioxide are released. The result? Foul odors, cloudy waters, greenhouse gas emissions, and even public health risks. Fish waste isn't just an industry problem, it's an environmental and community problem. So, why are we calling it a resource? Because fish waste is loaded with nutrients. On average, it contains 58% proteins, 19% fat, and essential minerals like calcium and phosphorus. You also get omega-3 fatty acids, which are crucial for brain and heart health. Skins and bones provide collagen and gelatin, which are used in food and cosmetics. Shellfish waste contains chitin and chitosan used for water purification and biodegradable packaging. What most people see as trash is actually a biochemical treasure chest. One of the most common products made from fish waste is fish meal. It's a high-protein powder used as feed in aquaculture, poultry, and livestock. Here's how it's made. First, fish scraps are heated to coagulate the proteins and release oil and water. Then, the mass is pressed to remove the liquid. The liquid is separated into oil and stick water while the pressed cake is dried and ground into meal. Fun fact, in 1988, most fish meal went to pigs and poultry. But today, over 60% is used in aquaculture, helping farmed fish grow faster and healthier. That's a perfect loaf of sustainability. Fish feeding fish. Next is fish silage, a liquid feed that can even be made from spoiled or low-value fish. There are two main methods of production. First one is the acid silage, where fish is chopped, mixed with formic acid and stored. The acid keeps the bacteria away while enzymes break the proteins into small digestible peptides. The second one is the fermented silage, where the fish is mixed with molasses and inoculated with Lactobacillus plantarum. The bacteria ferment sugars, producing acids that preserve and break down the fish. Silage can then be dried with cereals like wheat bran to make nutrient-rich animal feed. And this process is cost-effective, sustainable, and prevents spoilage. Perhaps the most famous byproduct is fish oil. Extracted from waste parts like livers and skins, it's rich in omega-3 fatty acids, especially EPA and DHA. The health benefits are massive. Protection against heart diseases, lower blood pressure, improved learning ability, and even better mental health outcomes. Beyond nutrition, fish oil can be used for biofuels, eco-friendly leather processing, and enzyme production. Extraction can be done through cooking, pressing, solvent extraction, or modern green technologies like supercritical fluids and enzymes. Think about it. Something as unpleasant as fish guts can fuel both your body and your car. Fish protein hydrosylates are proteins broken into smaller peptides using enzymes like pepsin or papain. Why is this important? Because smaller peptides are easy to digest and come with powerful bioactive properties. FPH is used in baby formulas, sports nutrition, soups, bakery items, and health supplements. It has antioxidant, antimicrobial, and immune boosting benefits, making it more than just a protein. It's a functional food. From fish skins, bones, and fins, we can extract collagen and gelatin. Collagen strengthens skin, bones, and joints, while gelatin is used in jellies, marshmallows, capsule shells, and bone dressings. Unlike cow or pig sources, fish collagen avoids disease risks like BSE and is culturally acceptable in many regions. This makes it a sustainable, safe, and increasingly popular alternative. It is rich in glycine, proline, and hydroxyproline for skin, joint, and bone health. Fish waste is also fueling the green energy revolution. Through transesterification, fish oil turns into biodiesel with high energy content and lower emissions compared to petroleum diesel. Meanwhile, anaerobic digestion of fish guts produces methane-rich biogas which can be used for cooking, electricity, and heating. Even the leftover sludge serves as fertilizer. Waste to energy is no longer a dream, it's happening. Fish intestines and livers are rich in digestive enzymes like trypsin, pepsin, and alkaline proteases. These are recovered through homogenization, centrifugation, and drying. Applications: they are used in detergents, pharmaceuticals, food processing, and environmental cleanups. Imagine enzymes from a fish stomach cleaning oil spills or tenderizing your steak. Shell waste, especially from shrimp and crab, gives us chitin and chitosan. Chitosan is biodegradable, antimicrobial, and can form films, making it perfect for edible packaging. It is also used in water purification, drug delivery systems, and even as a biopesticide in agriculture. This is one of the most exciting applications because it directly reduces plastic waste and pollution. It is employed in wound healing and drug delivery systems due to its biocompatibility and controlled release properties. It also acts as a natural biopesticide and is used in seed coatings to improve germination and protect plants from diseases. But here's the catch. These technologies require heavy investment, skilled labor, and proper infrastructure. Many small fisheries lack the resources or awareness to utilize fish waste properly. Regulations and safety standards are also unclear in some regions, showing slowing adoption. Additionally, limited awareness about the economic potential of fish waste combined with unclear regulatory frameworks in some regions further hinders the growth of this sector. Maintaining consistent quality and ensuring microbial safety is another concern, particularly when the end products are intended for food, pharmaceutical, or commercial use. Still, the future looks promising. Emerging green technologies, integrated biorefineries, and supportive government policies are pushing this sector forward. Global demand for omega-3s, collagen, and biodegradable materials means fish waste utilization is only going to grow. So, the next time you enjoy a fish meal, remember, what you don't eat could be powering cars, healing wounds, or protecting the planet. Fish waste isn't garbage, it's a valuable resource that can transform industries, improve health, and support sustainability. If you found this video eye-opening, make sure to hit like, share it with your friends, and subscribe for more deep dives into science and sustainability. Together, let's spread the word and turn waste into wealth. Picture this.